This is me, pulling a string on crappy 5-minute print job and trying to get a cool footage like this. But it's horrible to use, it has horrible results and overall. So let's build something better. First order of business is to replace a string with a motor. I went online and searched for hours, until I found this marvel of engineering. I bought this little guy with incredible 0.00000266 horsepower. But more importantly, it's geared down only to 30 RPM, which, believe it or not, it's still pretty fast, so we will gear it down even more. I've 3D printed many gears over the years, with some more useful than the others. But what type of gear is best for the job? I want to make this build as small as possible. With the simplest choice of spur gear, the motor itself would have to be parallel to the rotational axis of the table. This would mean a tall assembly, which is a no-go. Helical gears with 45-degree helix are great and give us a perpendicular shafts. We can take middle gear as a drive gear, and this gives us 1-to-1 reduction to the right and 3-to-1 reduction to the left. But we want to reach reduction somewhere between 20-to-1 and 30-to-1, which is not possible without stacking multiple gear sets. So this leaves us with the final option, the absolute powerhouse, the worm gear. Worm gears are used for high speed reduction ratio, especially if you are limited by space. You can easily achieve 100-to-1 ratio or more in a single stage, which is perfect for our application. What you see here is a ratio 30-to-1. Size is significantly smaller compared to helical gears from before, and that's only with reduction 3-to-1. If we wanted the same reduction ratio, yeah, you can get the idea. So after whipping a quick prototype, we can go over electronics. Well, there is not much more than this 3-volt motor. But why this one, you may ask? Because I found this one to be the smallest, slowest and cheapest out there in the wild. Next, we need to power it, but I want to do it with 5V with something like a USB, or my trusted barrel plug. Then the only thing left is to step down the voltage from 5 to 3 volts. After a quick soldering, we are ready to put the first prototype together. First is the motor and the worm thread. Then the bearing for smoother operation. And the worm wheel, which will later drive a plate on top. As you can see, it works as intended, but there is a bunch of loose tolerances from closer look. And my perfect motor is not so perfect anymore. That's exactly why you need to prototype small pieces or segments before printing complete parts, otherwise it's just a complete waste. Let's improve what we can. Adding a bearing to motor shaft, adding a second bearing and support shaft. Adjusting tolerances, making a guard for gears, completing the bottom housing, and making room for electronics. But with everything almost done, we need to solve the last puzzle piece. The blade, the cover, the top head, the thing which will sit on top. That's why I prepared these beforehand. These two are made from oak, with the only difference is that this one has a hole in the middle. I know, a shocker. My original plan was to extend this axis and locate the center using this hole. But I came up with a better solution. This intermediate piece will simply clip to the gear. We can put screws through the pins and we can screw it to the wood from underneath. No more ugly holes going through. The only thing is to locate the middle. We can locate the middle with simple fixture. Marking the center and screwing the intermediate piece in. We can locate the middle with simple fixture. And with the screws in, the only thing left is the final assembly. Assembly steps are same as before, except now we have a bearing here to help with wobbliness. And a bit of grease so this thing doesn't die immediately. Same bearing on worm thread and these M3 screws which will support the thread for more wobbliness reduction. Barrel plug is pressed in and two M3 screws help to secure the step-down module. Another bearing slides in, followed by the worm gear, but now with much better tolerances. Finishing it with the cover clipping to the gear. And all that for 5 seconds of video. Wait, you would think I would use only 5 seconds after all this effort? Everything will spin from now on. Enjoy! Thank you for watching and see you next time.